Morning guys, we are from the KIG2001 Fundamental of Electrical Engineering, and we'd like to share to you what are the types of AC motors and brushless DC motors. So my name is Chuan, and with my partner will discuss more about it. So actually there are two types of AC motors, which is induction motor and synchronous motor. So I will talk more about induction motor first. So why do we use induction motors? It's actually to produce torque by the electromagnetic induction. So how do we do that? So there are actually two types of AC motors, which is squirrel cage rotor and the wound rotor. So the wound rotor motor is actually, they are used by the windings connected through the slip rings to the external resistance. Later I will talk more about why do we use slip rings, and it can be started with low inrush current. What is meant by low inrush current? Means that you can use a low amount of current to produce the torque. And actually, this is the second type of the rotor, which is squirrel cage rotor. It's made out of a cylinder of steel lamination. So this is the image of a squirrel cage rotor. This part is the stator, and this part is the rotating part, which is called rotor. So how do they work? So this one is the example of a three-phase squirrel cage. As you can see here, this part is a fan cover, this one is a cooling fan, this one is all the application part, and this part is the one we are focusing on. So this part is actually the stator, and it's made out of a thin slag of steel lamination inside a cast iron frame. And this part is the rotating part, also we call as a rotor. So when the AC current comes in, and the rotor rotates. According to Faraday's law, when something is rotating under a magnetic field, under a inrush AC current, it will produce a magnetic field. So according to the Lorentz law also, when the rotating part is rotating under a magnetic field, it will produce a force. So the force is actually parallel to the surface, which is like this, the force, and one is up there. So it's actually an anti-clockwise rotation. So this part is the basic mechanism of the three-phase squirrel cage. So how about the wound rotor motor? As you can see here, this part is the slip rings, and these are the special part of it. So actually this can be used to produce a high-end torque. So as you can see here, they are almost basically the same thing, just the difference are the slip rings. So the slip rings are actually connected to the external resistance. When the external resistance increases, it will produce the maximum torque of it. So the law is actually the same. This part is the stator, this part is the rotating part. So when it rotates inside, it will induce an electromagnetic induction. So how about the synchronous motors, as we can see just now? This one. So they are basically the same. This part is the stator and this part is the rotating part. So I would like to talk more about the types of the synchronous motor. So actually, what is synchronous motor? At the steady state, the rotation of the shaft is synchronized with the frequency of a supply current. For example, when the current flow is like 5 ampere, then the rotating shaft will try to synchronize with it so they can rotating together. And it contains multi-phase AC electromagnets on the stator. So this one is the first example, which is non-excited motors. It's made out of steel, and it rotates in step with rotating magnetic field of a stator. And the external stator field magnetizes rotor and rotates. So actually the stator are made out of a lot of electromagnets, and when it connects, it will magnetize the rotor and causes it to rotate. So this one is the second rotor, which is reluctance motors. So the rotor consisting of a solid steel casting with projecting tooth poles. And there are fewer rotors compared to the stator poles because to minimize the torque ripple.
Alright, hi guys, my name is Yachi. So what I'm going to talk about now is when are AC motor and brushless DC motor used, or known as the applications for both. Okay, let's start with our application for AC motor. The first one is it is used to improve energy efficiency. So, industrial motor efficiency is now improved upon with many new design aspects. They are even using thinner laminations in the rotor stick. A new method is using higher grade electrical steel laminations that can improve the insulations of the rotor as well. The second one, high efficiency synchronous motors. The main type of this kind of motors are switch, reluctance and permanent magnet motors. They include salient poles in the rotor that serve as teeth in the rotor. They lock at speeds using the magnetic field. And these motors include more permanent magnets that can be mounted on the surface or inside of the rotor. So these motors are also used in speed controllers and other precision based drill machines and other devices that are similar in function. Right, the third one, universal motors. So universal motors are the more generate of AC motors. They can be used on both direct currents or alternate currents. They have a high constant rotary speed, and they are used widely in area applications like high power engineering, railway traction, and commercial drill machines. Next one, adjustable speed motors. So adjustable speed motors are great because they have a much needed feature in terms of their management and speed control. And they are used in applications such as electrical power plants, marines, cargo pumps, etc. Right, the last one, linear motors. So these motors are the least conventional of the group, which create a linear power to either pull or push something for a set length. So it is used in monorails, roller coasters, and other transportation machinery. Okay, now let's talk about the application for brushless DC motor. So the first application is linear motors. It produces linear motion without the need of a transmission system, such as a ball end, lead screw, brake and pinion, cam, gears, or belts that would be necessary for rotary motors. So, as direct drive linear motors, brushless DC motor have the added advantages of maintenance-free operation with no mechanical connections, hysteresis, or pitch clinical error. Okay, the second application is servo motors. Servo motors are used for mechanical displacement, positioning or precision motion control based upon an input control and output feedback signal that establishes a tightly controlled, stable, closed-loop operation. So these are more suitable as brushless DC motors are more suitable as servo motors due to the feedback capability of this motor. Okay, the third applications is actuators for industrial robots. So permanent magnet DC motors primarily function as the actuators to move the joints of industrial robots for pick and place or to positioning in assembly, welding, and painting operations. It merits noting that when heavy payloads are involved, hydraulic motors are typically used. So these motors are patterned over brush motors in robotic applications due to their compact size, power density, and maintenance-free characteristics. And they also perform more reliably in less favorable or hazardous environments. Okay, now, do you know how AC motor and brushless motors are controlled? Okay, let me explain about it. The first one, how AC motor is controlled. So, AC motor is controlled by AC controller. An AC controller, sometimes referred as a driver, is known as the device that controls the speeds of the AC motor. An AC controller can also be referred to as a variable frequency drive, adjustable speed drive. So that's all from me, and I would like to pass the floor to my partner, Mr. KHOR. Thank you.
Good morning everyone, my name is KHOR, and now I want to explain to you what's the difference between the AC motor and the DC motor. First, for the supply, AC motor works on AC supply, which is involved the electric current that change back and forth over time. For the DC motor, is used direct current, which from the power source from batteries, solar cell, and DC power converters. For the starting point, AC motor needs starting mechanism for the single phase, not for three phase. But for DC current, it can start by on. For the supply system, AC current can be single and three phase, but the DC motor is just single phase. For the starter and rotor actions, AC motor starter remains standstill and supplies rotating field while rotor rotates. But for DC motor, the armature rotates and the field winding remains standstill. AC motor do not have bruiser and commutator. It's very rich and have a very long life. But for DC motor, it has a bruiser and a commutator, which limit the speed and reduce the life expectancy. Compare the AC motor and DC motor lifespan and life expectancy and cost. AC motor can last long and withstand rush condition, provide power over long stretch of time, and is inexpensive. Compared to DC motor have a shorter lifespan, expensive to replace once damaged and or worn down. It's very expensive. For the speed control, this AC motor is controlled by changing frequency, but DC motor is controlled by changing armature winding current. For the speed and torque, AC motor have a use for high speed and variable torque, but DC motor used for variable speed but very high torque. For the load change, AC motor slow respond to change in load, but DC motor is very quick respond to the load change. For the efficiency, AC current has low efficiency because induction current loss and motor slip. But for DC motor, it's more efficiency since no motor slip and induction current loss. Compare the armature location. AC motor armature remains stationary and magnetic field rotates. But for DC motor, the magnetic field remains standstill while the armature rotates. Compare the use of AC motor and DC motor. AC motor are permanently used in large industry and factories, but DC motor is used in the domestic applications. As for the maintenance, AC motor requires less maintenance because of the absence of bruises and commutation process. But for DC motor, it demands extensive maintenance frequently. Now I want to compare the size of the AC current and DC current. This current has a larger size compared to AC current. DC motor has a larger size compared to AC motor, but DC motor has commuter and bruiser, but that's not the reason why DC motor is larger. DC motor rotates, rotor has winding, unlike not like AC motor rotor, which is just compact in size. The main reason why DC motor is bigger because it has an internal cooling system. DC motor rotor and stator both need cooling system, and it must accommodate internal fans or external separate blower. So AC motor is used external cooling system, so it's have a smaller size compared to DC motor. So now for the conclusion, compare DC motor and AC motor. DC motor are typically utilized in application where the speed has to be controlled by some external source. AC motor is operated better in such application where power efficiency is required for a longer time. AC motor are single phase as well as three phase, whereas DC motor are single phase always. In certain application, DC motor are substituted with an AC motor, which is connected with an electronic speed controller. This is connected assembly is called variable frequency drive, VFD. DC motor comprise of moving parts that are costly to replace, and repair is generally more expensive than utilizing an AC motor with an electronic controller. That's all for me. Thank you.